Hello everyone, and welcome to another safety meeting. This is October safety meeting. We'll be going over electrical safety. There's things we're going to touch during this meeting. Introduction. An average of one worker is electrocuted on the job every day. There are four main types of electrical injuries: electrocution, which is death due to electrical shock, burns, and falls. Some electrical terminology is current, the movement of electrical charge; resistance, opposition to current flow; voltage, a measure of electrical force; conductors, substances that have little resistance to electricity; insulators, substances that have high resistance to electricity; and grounding, a conductive connection to the earth which acts as a protective measure. Electrical shock, received when current passes through the body. Severity of the shock depends on the path of the current through the body, the amount of current flowing through the body, and the length of time the body is in the circuit. Low voltage does not mean low hazard. Dangers of electrical shock. Currents greater than 75 milliamps can cause ventricular fibrillation, rapid and ineffective heartbeat. Will cause death in a few minutes unless a defibrillator is used. 75 milliamps is not much current. A small power drill uses 30 times as much. Remember, milliamp, the little m big A is milliamp. It's 1/1000th of an ampere. How is an electrical shock received? When two wires have different potential differences, which are voltage, current will flow if they are connected together. Most household wiring, the black wires are at 110 volts relative to ground. White wires are 0 volts because they are connected to ground. If you come in contact with an energized black wire, you are also connected with the white grounded wire, current will pass through your body and you will receive a shock. If you are in contact with an energized wire or electrical component and any grounded object, you will receive a shock. You can even receive a shock when you are not in contact with ground. If you are in contact with both wires of a 240 volt cable, you will receive a shock and possibly be electrocuted. Electrical burns is the most common shock-related non-fatal injury. Occurs when you touch electrical wiring or equipment that is improperly used or maintained. Typically occurs on hands. It's a very serious injury that need immediate attention because you don't know what's going on inside your body, because that's where all the electrical takes place. Falls. Electric shock can also cause indirect or secondary injuries. Workers in elevated locations who experience a shock can fall, resulting in a serious injury or death. Inadequate wiring hazards. A hazard exists when conductor is too small to safely carry the current. An example, using a corded tool with an extension cord that has wire too small for the tool. Tool current is greater than cord capacity. This causes overheating, possible fire without tripping the breaker. The breaker is the right size for the current but not for the smaller cord. Overload hazards. If too many devices are plugged into a circuit, the current will heat the wires to a very high temperature, which may cause fire. If the wire insulation melts, arcing may occur and cause a fire in the area where the overload exists, even inside the wall. Grounding hazards. Some of the most frequently violated OSHA standards. Metal parts of an electrical wiring system that we touch, switch plates, light fixtures, conduit, etc., should be 0 volts relative to ground. Housings of motors, appliances, or tools that are plugged into improperly grounded circuits may become energized. If you come in contact with an improperly grounded electrical device, you will be shocked. Overhead power line hazards. Most people don't realize that overhead power lines are usually not insulated. Power line workers need special training and PPE to work safely. Do not use metal ladders, instead use fiberglass ladders. Beware of power lines when you are working with with ladders and lifts. Also be sure to remember that your minimum working distance on a lift to a power line is 10 feet. Electrical protection devices. These devices shut off electricity flow in the event of an overload or ground fault in the circuit. These include fuses, circuit breakers, and ground fault circuit interrupters, or GFCIs. Fuses and circuit breakers are overcurrent devices. When there's too much current, fuses will melt or circuit breakers will trip. Ground fault circuit interrupter. These devices protect you from dangerous shock. The GFCI detects a difference in current between the black and white circuit wires. This could happen when electrical equipment is not working correctly, causing ground fault. If a ground fault is detected, the GFCI can shut off electricity flow in as little as 1/40th of a second, protecting you from a dangerous shock. OSHA electrical requirements. Some examples of OSHA electrical requirements are grounding path. The path to ground from circuits, equipment, and enclosures must be permanent and continuous. Violation shown here is an extension cord with a missing grounding prong. Handheld electric tools. Handheld electric tools pose a potential danger because they make continuous good contact with your hand. To protect you from shock, burns, electrocution, tools must have 3-wire cord with ground and be plugged into a grounded receptacle, or be double insulated, or be powered by a low voltage isolation transformer. Guarding of live parts. Must guard live parts of electric equipment operating at 50 volts or more against accidental contact by approved cabinets or enclosures, or location or permanent partitions, or elevation of 8 feet or more above the floor or working surface. Mark entrances to guarded locations with conspicuous signs, warning signs. Grounding of live parts. Must enclose or guard electric equipment in locations where it would be exposed to physical damage. A violation shown here is physical damage to conduit. Cabinets, boxes, and fittings. Junction boxes, pull boxes, and fittings must have approved covers. Unused openings in cabinets, boxes, and fittings must be closed. No missing knockouts. Photo shows violations of these two requirements. Use of flexible cords. More vulnerable than fixed wiring. Do not use if one of the recognized wiring methods can be used instead. Flexible cords can be damaged by age, door or window edges, fasteners, abrasion from adjacent materials, area activities. Improper use of flexible cords can cause shock, burns, or fire. Permissible uses of flexible cords. Pendant or fixture wiring, portable lamps, tools or appliances, stationary equipment to facilitate interchange. Prohibited uses of flexible cords, substitute for fixed wiring, run through walls, ceilings, floors, doors, or windows, concealed behind or attached to building surfaces. Clues that electrical hazards exist: trip circuit breakers or blown fuses, warm tools, wires, cords, connections, or junction boxes, GFCI that shuts off a circuit, worn or frayed insulated wire or connection. Training. Train employees working with electrical equipment in safe work practices, including de-energizing electric equipment before inspecting or making repairs. using electric tools that are in good repair, using good judgment when working near energized lines, using appropriate protective equipment. Summary: some of the hazards are inadequate wiring, exposed electric parts, wires with bad insulation, ungrounded electrical systems and tools, overloaded circuits, damaged power tools and equipment, using the wrong PPE and tools, overhead power lines. All hazards are made worse in wet conditions. Protective measures: proper grounding, using GFCIs, using fuses and circuit breakers, guarding live parts, proper uses of flexible cords, and training. If there are any questions, please contact me either at the shop or my cell phone is in the email. It's the end of October, so I hope you all have a happy Halloween. And make sure you get your fire extinguishers checked and signed off. Make sure you go vote. Important, go vote this year. And also, I hope you all have a good next month, and we'll see you out there. Be safe.